All right, so I am still kind of sick, but not sick enough to not talk about batteries. So let's talk about batteries. I want to talk to you guys about these batteries in particular. They are 6,200 milliamp hours, pouch cells. They are 50C, which means that they can put 50 times their own capacity, which is some crazy amount. These are super duper batteries, right? These are super batteries right here. 22.94, so almost 23 watt hours. So they're not huge. I mean, they're like almost the equivalent of two 18650s, right? And they're about equivalent size, so they're not too bad. They come like this. And I've talked to them about them before on my channel because I got this last year, and it's a small amount. We don't have a lot of them, right? But we do have enough to build some cool stuff. Now we've had these on the website for a while, but since I've never really made a video talking about how you can build a pack with them, then I think people haven't been buying them too much, right? Only the people who know what they are and what they need. So these are very specific batteries. Like, not everyone needs these, right? These are batteries that can give you their energy at 50 times their capacity. So these are power batteries, power dense batteries, right? So what I ended up doing is, let me show you here. One of the interesting things about these, there we go. It's, or one of the reasons why I hadn't built something like that is because these are kind of dangerous. Just because of the fact that they can push so much power, right? So check this out. Something of interest here is that the positive is made out of aluminum. The positive terminal, right? The negative is right here. It's made out of copper. This is made out of aluminum, so they put another little copper thing at the end so that you can solder into here. These, the only way you can assemble these is if you can solder into them. They're not like 18650s where you're trying to figure out some way to weld or whatever. So what I ended up figuring what to do is to just push it in like that, and then all of a sudden now you have copper here, and then now you have copper there, and now you can solder into a board. And I made these boards in here to be able to do that, right? And so then you just slide them. They have these little holes in there, and then this is the positive, and I marked them all positive and negative, and then you just push them in there, and then you solder them. So this is not my idea. This is a thing that people have been doing for a long time. They've been using PCB boards to solder into flat tabs on these LiPo style cells, right? And I just wanted to try it and see. This is my first iteration. I think there's some improvements that I can make, and I'll show you. We'll go through those right now, but I just got those, and then I got working on making the battery, and this is what it looks like. This is a 14S. 52 volts, right? Or what the e-bike world calls a 52 volt battery. For everyone else, a 14S, it's a 48 volt. But in the e-bike world, it's a 52. And, you know, the reason why I call it a 52 is because this is probably really good for a high performance, super high performance e-bike pack, right? And so e-bike project. Now, what does the 50C mean, right? This is 322 watt hours, right? So it's not the biggest battery that exists, right? There are usually about twice as that for most of these e-bike batteries. They start somewhere around half a kilowatt to like 1 kilowatt, and this is 0.3 of a kilowatt, right? So if you add 2, then that's about 600 watt hours, so 0.6 of a kilowatt, right? So but the interesting thing is that this thing could get this. At 300 amps, at 52 volts, that's 15 kilowatt. This thing is capable of 15 kilowatt output. That's a huge amount of power. I mean, even to test it, I'm like, how am I going to test that? The biggest inverter that I have here is an 8 kilowatt inverter, so that's not even enough. I would need to have 2 of those inverters just to test this tiny little battery here with enough to see how this PCB is going to handle the 300 amps, right? So that's where this is at. 15,000 watts. This battery here can do that much, right? So I don't know. It's hard to wrap around your mind how much energy is possible in here. And so it is kind of dangerous when you're soldering in here, because if you short it out, well, you're going to see 300 amps, and everything's going to melt immediately. So you kind of, when you're putting this together, you kind of can't make any mistakes. And so that's why I'm putting a lot of attention on how I'm building this PCB board to help you prevent any kind of mistakes, And so what you end up doing is putting the tabs in there, then soldering them, and then immediately covering them with Kapton tape. And then, you do the other one, and then you sort of do and that's sort of, you go like that way, right? And so what do you do after you're done with this pack, though? Let's talk about that. Well, what about the BMS, right? So here are all the balance leads, right? I put this little connector, and this is one of these connectors that we've been using of all the other projects and stuff. So it's kind of a known connector for us. And so that's why I ended up using that. Well, let me show you if you wanted to use a BMS, and maybe why you wouldn't want to use BMS. Here is a 200 amp BMS. This is 10S, right? But they do make a version that's 14S, 200 amps. And I mean, look at it. It's literally, well, it's a little bigger than the battery. And look at these cables. They're so giant, right? Now, why are these so giant? And I think the reason why is because this is made for a 200 amp continuous, right? And so then you need these beefy cables to be able to do continuous, right? So how is it possible that this tiny little bus bars, right, can handle 300 amps? But this thing needs this giant cable, a 2-aught cable. Well, these are not rated 300 amps continuous. Those are bursts, right? So if you load this battery with 300 amps, it's only gonna last like a few minutes, maybe a minute or two. You do the math, right? Like, it's not gonna push a lot. So these are gonna get hot, but they're not gonna melt because these are rated for that, right? So they wouldn't build a battery that can put out 300 amps, but the little terminals, bus bars coming out of it would melt way before that. So obviously these can handle the 300 amps for an X amount of time, a few minutes. And then after that, the battery's completely dead. So then you're moving on, right? So now the only thing to do is to test to see that this stuff that I'm doing here can last, can withstand 300 amps for about the same amount of this one, right? And so what happens is that because the BMS would have to be so big, these packs that are at this, level or whatever, usually don't end up using BMS systems on them. What they do is they build them in a way that you have all the leads out so that you can balance charge them. And this is something that if you come from if you have an experience in the RC world, you completely understand this concept. But if you don't, then it might be new to you. And so here, what I have here is it's showing you two chargers that are made for the RC world. And this one's 6 cells and this is 8 cells. So together would equal about 14 cells. And so what you would do is make a cable that's special that goes from here, and then they go into the balance leads of these two. And then you would go from the positive to the negative, and then the two outer positives and negatives, then you put in here. And that's how you could charge a 14S battery using two of these chargers. You could totally do it with these chargers, and you can charge at about a rate of 1,000 watts, right? So the balancing that the BMS would end up doing On a traditional battery, these things do it. They have the BMS built in here, and they just balance the cells as they're charging them. And so you'd have to balance charge this battery every time, right? So that's one way to do it. And then now you just have a connector from the main terminals, and then you go to your load. And that is usually what ends up happening on an RC project that would use something like this, right? So you skip the BMS because the BMS would end up being so huge and so big, and that it's not feasible, or it's just better to not use it, just to use the BMS only on the charge side of the thing, right? So now that you understand that, let's look at how we can improve this further, and then make the changes on our PCB software over there, and then just do that, right? Okay, so this is what the board looks like, right? And then you can do the 3D render here. Come on. Okay, so here we go, right? That's what it looks like. These are the traces, right? So the energy on these pins, so the current is not really traveling through the board. It's just traveling through a big lump of solder. And so the only way and the only place where the energy or the power is traveling through the board is through these ones. And the reason is because they're separated by about 10 millimeters of distance between those two, right? Well, now that I built the actual battery here, and you can see it, every time you get that, now I realize that I could just combine those, put them really in the center of the two cells in here, and I can combine those without the need of having to go through this, right? And I did these little exposed areas of the copper there, just so that we can build it up like this, right? So it will handle. This is a common practice that people do, PCB makers use to be able to carry or handle more current, right? But I realized that we don't have to do that. They can look exactly the same as these ones if we just combine them, push them together. And I didn't know if that was possible just to the way the cells are aligned. But now that I build it, it's like, oh yeah, there is a way to do it. It wouldn't actually be that hard to do it. It wouldn't mess or interfere with anything. And so I can get rid of all this and make it much simpler and better, cleaner looking if I just combine those. So we can do that now. And the way we do that is, well, let's see. So if we do this, so here is the first one. And what we do is we just grab that one. So let's put a mark in sort of in the middle, right? There we go. And so then what we do is we just move that there. And then we grab this one, and then you just move that one there. Look at that. So here we go. Let's move that one a little bit down here. Okay. So now we don't need this pad to be this big. Now we need this pad just a little bit bigger than that area there. And then we definitely don't need any of these because, well, they don't need to be exposed like that. Right, and then this is the pad on the back side, so we just make it smaller also. Okay, now the balance lead is here, so we will need to go this way. Oh, there we go. That works. So now that's connected in there. Huh. Okay. So that's the first one, right? And now what we need to do is go to the second one over here and do it again. All right, and there we go. We just made those changes. We moved all those, and now it's gonna look a lot cleaner. And there's gonna be shorter pathways, so there's less chance of the failure, right? Due to such a high power going through the pathway of these the PCB material. So there you go. This is the 14S version. This could be made. You can add, you can take 4 of these cells off, and then that's a 36 volt version. You can add an extra, well, what is it, like 6, right? 14, yeah. So you can make a 20S version of this, and then that would be a 72 volt version of this thing that could do 50C. So again, remember, this is not just your average battery to be able to power your average thing, right? Think about a race car, a little car, maybe a go-kart. You put couple of these batteries, you put them in there, boom, all of a sudden you could, right? So what's 15 kilowatt? That's 6 horsepower. So each one of these could do 6 horsepower. You put 2 of them, you're at 12. You do 3, 4, right? You're like, car level power. And so, yeah, if I put 30 of these in series, I could power my entire bus. Full power, 300, well, no, because it's 600. I would have to do 60 of these cells, could power my car full power, right? 80, 72 kilowatt or something like that. So think about this. Yeah, if you're making some high performance e-bike, if you want to charge something really fast, right? Let's say you want to make like a little pack that you can charge your electric car, maybe, I don't know, put like a kilowatt of power into it, but you want to do it in 5 minutes. This is the battery that would be able to do that, right? And so if you want to start some big machinery and it takes a little battery, this would be like a kick start, like a jump start pack right here. You could do these in 4S if it's a 12 volt thing, right? But other big machinery might require a different voltage, and so that's what this is. And so I'm gonna make these available. I'm gonna make the different versions, the 10S, 14S, the 20S, 4S, I guess too, right now. And then I'm gonna put those in PCBWay.com, and then you can go there and download them, and then you can populate your own batteries using these cells right here, and you can make the battery that you might need, right? If you need lots of power, well, these cells right here are as good as it gets. I mean, there are cells that could put more power than that, but there's not a lot of them. These are they're kind of rare, right? And so we had a chance to get a batch of them that are brand new, unused, and I think people just have not been building with them, just because I think a lot of you guys are probably there that don't know what you're looking at. And hopefully this will enlighten you a little bit and make it much more clear of what it is that these are and why they're so amazing. So there we go. Hopefully this was somewhat educational. If you learned something, then I have succeeded. If not, at the very least, maybe it was entertaining in some way or shape or another. I want to thank you for watching these videos. I want to thank you for all your support, and we'll see you guys in the next one. Stay busy, stay building batteries. We all need batteries, and if you know that, then you're ahead of the curve. You're ahead of the game. I think the average person doesn't know it yet, but the need for batteries is coming, and they're gonna have to either buy some, and us that are building our own, well, we're gonna be in such better shape to diagnose and to, just knowledge is power, right? And so there you go. Thank you for that. We'll see you on the next video. We'll see you. Bye.